This brief video addresses bases. Our strong bases. The strong bases are all soluble metal hydroxides, and they do dissociate 100%. So if we recall, we can use the aid of the periodic table, and we take the lead of the first three alkali metals, so lithium hydroxide, sodium hydroxide, potassium hydroxide, then over calcium, strontium, barium hydroxide. We understand these being soluble will dissociate 100%. So if we would have a solution of 0.5 molar sodium hydroxide, well, we understand that will dissociate to give us then 0.5 molar of hydroxide. Where if it would be 0.5 molar calcium hydroxide, we just have to be on guard to realize, of course, we're going to get 2 hydroxide ions for every 1 calcium hydroxide. So the concentration of this will be 1 molar in that case. Otherwise, now, with the amount of chemistry that we've had, we're really, we'll be given little hints within the problem to let us know if we're dealing with an acid or a base, which I'll reveal one of those main hints in just a moment. But for our work this year, the main go-to weak base will be ammonia. All right, so if we have ammonia, and if it is behaving as a base, what do bases do but accept the hydrogen ion? So if this accepts a hydrogen ion, we will be forming ammonium and then hydroxide. So strong bases contain hydroxide and then liberate it in aqueous solution, where weak bases make hydroxide. And it's the hydroxide that's responsible for all the different characteristics that we associate with bases. So if we would write a K expression, it would be the conjugate acid of our weak base times hydroxide over the concentration at equilibria of our weak base. So it's different. Remember, Ka is the hydronium conjugate base over concentration of weak acid. Well, Kb, which would be the equilibrium constant for base behavior, is we're creating the conjugate acid and hydroxide beginning with the equilibrium, or divided by the equilibrium concentration of our base. And again, water does not show because it's a liquid state. Just like weak acids, we would anticipate that Kb values will be less than 1. We will be favoring reactant. We only partially have this forward reaction. So that is what we will apply. We have to know if we're dealing with a base, and usually we know if a chemical formula that we're unfamiliar with is behaving as a base. You'll be given the Kb value of it. Then we know, okay, to get our equilibrium reaction, it will accept the hydrogen ion and understand how Kb is different from Ka.